And right now I'm not even looking at the chat. So if somebody told me, tried to type it up, I wouldn't have noticed. Thank you. Okay, so if you have a projectile motion question which mentions the speed, right? So I'm going to highlight that. So this is something you should have on your study sheet just in case, okay? If they give you some kind of speed, which will be most likely meters per second, then you got to use this formula, which is negative 4.9 t squared plus initial velocity. Okay, this is not a zero, this is just a initial velocity, just like we used to do like delta time and all that. That's just a notation thing. And this is followed by initial height. So this is the formula we use, right? Where V0 is the initial velocity and this is the initial height. So it's actually not that bad to do these, but you need to know that this is where you grab your formula from. It's like, oh, initial velocity, I remember, right? It's that special case, right? And then you just go ahead and fill this in. So we'll do an example of where we have to use one of these, right? So Bonnie launches a model rocket from the ground, with an initial velocity of 68 meters per second. Right? Bonnie's friend is watching the launch, right, from a lookout point at a safe distance. Her friend's eye level is 72 meters above ground. So we're going to do a couple of things. Determine the domain and range. How long until the rocket reaches her friend's eye level? Question mark. Graph the scenario. So write this down. So I'm assuming when I'm writing, you are writing. Okay, so just make sure you always stay on top of the notes. And I mean, this is also recorded. If you do miss anything, just go back and get it, right? If I, by any chance, I'm trying to slow down. And there it is. So there's a velocity or speed, right? I'm assuming you know that they mean the same thing, right? Velocity and speed is the same. And that should be an indicator that you're going to have to use that formula, okay? So for A, before you can even attempt to answer anything, you need the equation, right? You won't be able to do that without an equation. So you need equation, speed mentioned, use this one. Okay. The initial velocity is 68 and the initial height is 0 because you're starting right on the ground, right? It's stated in the question. So we essentially substitute in these values into your equation, and that's all there is to it. And now you have your equation. So no need to find any points. Okay, so this is just 0, so we're just gonna kind of state it like that. And notice that I'm jumping right to domain and range. I'm not even asking you to come up with the equation. I'm not even asking you to find the x-intercept, the vertex. None of that is mentioned, right? So you have to be prepared for something like that, right? I'm assuming you would know, okay, for domain, I need a couple things, and for the range, I also need my vertex, right? So keep that in mind. I would always suggest to have a little bit of a sketch, right? So in this case, if you have the height and time, because that's, right, it's implied that time is your x, right? And this is your height. And I'm just sketching, I'm not graphing. So we're starting off the ground, it's going up, and then back down, hitting the ground here. Okay? There's a lookout tower, right? Right, where the friend is watching this whole thing unfold. And we know that this is 72 meters, right? 72 meters is the height above ground. Okay, so to find the domain and range, right? For domain, right, it doesn't say that it's stopped mid-air, right? We're assuming we need this, and we need the vertex. So let's go ahead and find those two in order to do that. So to find the vertex, it's just second trace max, right? I'm going to put the keystrokes down, and I'm going to come up with the actual points. So let's go ahead and type this into our calculator. Notice, just a little note, okay? So if I go to y equals, there's a bunch of stuff in there. I'm just going to turn off the front light. Okay? So you notice that I have a bunch of stuff in there. Now I'm not doing a regression. I'm actually just entering the equation manually, right? So I clear everything that's there. I turn off plot 1. You don't want anything to do with plot 1, or else it will interfere with the points you have in L1 and L2. Okay, so let's go ahead and plug it in. Probably almost don't remember how to do that anymore, right? So you've been doing regressions for the last couple of days, right? So instead of t's, we just put an x, right? And then go ahead and graph it. Let me just scooch this up a bit. Based on what I have, right, I can see that it's going up here. So I need to increase the y max and the x max at the same time. I do have my origin in here, so that's good. So x max, it looks like we're going to need a significant amount. So I'm going to go 150 there. I'm going to try 300 for y max. Let's just see what happens. Oh, yeah, that was plenty. So my x max is way too far. So I'm going to at least, let's try 50. So it's a third of what I had. I'm just looking at my screen. I'm like, I can reduce that significantly. This is good enough, right? So let's go ahead and find the vertex. Seeing that my cursor is now gone, right? I can't see it anywhere on the curve. But you have called maximum, so you are performing the max. So you just have to look at the coordinates. So if I go left, it's slowly coming towards me, right? I can see that it's coming up, so I'm just gonna, there it is, right? So go to the left, the right, enter, enter, and it's 6.94, right? Rounding. Some of you need practice with that, right? 235.92. Okay, so I write that down because I'm going to need it for my range, right? And I'm going to find the x-intercept now. So there's my x-intercept. I know I'm going to, somewhere in here, tell Mr. Dirksen how I found that. Okay? And the x-intercept is going to be second trace 5. Oh, I'm going way far. Okay, I'm going to have to come back. There it is. Again, enter, enter, enter. So that's 13.8, 13.88 if you round it, and that's 0, which you expected. Okay, so there it is. And let's state it here. So now I can finally take care of the domain and range. My domain goes from 0 to the x-intercept, which is 13.88. My range is, it's 0 is included, right, to the top, which is 235.92. And there it is. You've now finally answered the domain and range. Sketch is very important. If, right, it's just easier. You can make it even smaller than this, but just so you know where do we put the values, right? Where do we put those numbers? Do a little sketch. If you want to do it on scrap paper, go for it. But make sure you show the keystrokes whenever you are finding something, right? It's just, it takes maybe 3-4 seconds, right? And then you're done. And then you don't risk losing marks for that. I'd like to see it whenever possible, okay? Or whenever needed, actually. That's what it is. Like whenever you're using your calculator to find a point, somewhere around it, put your keystrokes, okay? All right, so that's determine the domain and range. How long until the rocket reaches her friend's eye level? Now that is a tricky one, okay? Because I will do B here. And I think this is from a textbook somewhere that I grabbed, right? I am assuming they're talking, right? Like, because we know that this is 235 meters here. So I'm assuming that, right, we're talking about the second instance here, closest to the friend, right? When is it at the eye level here? So this is the one we're interested in. So we're going to go y2 is equal to 72 because that's the height of the eye level. Second trace 5. We're going to go ahead and find that. There it is. So if you're not sure on a test quiz, you could say it happens twice, but I'm assuming it's the second one, right? State your assumptions. So 12.72. It takes 12.72 seconds. Done. And the last one, your favorite, is graphing, right? So I'm gonna go ahead and graph this. Use your ruler. You go ahead and graph it, okay? I'm just gonna leave that on there in case some folks are still copying it. I'm gonna make the graph on the side. Time, seconds, right? Height. What are we in? We're in meters, right? Everything is in meters when it comes to height. So just to clarify, speed is not part of your graph, okay? It's just to basically fill in the coefficient here for x, okay? So here it is. I need to account for 13.88 in terms of time, right? So if I go 5, 10, 15, 20, that's plenty, right? As long as you're consistent. This is your 0 here. This is my 0 here. And I need to go all the way to 235. So 100, 200, 300. That'll do. So you start at 0, 0. I'm going to have the vertex that's 6.94, 235, and you're landing at 13.88, right? So you curve up and over, down, 6.94. This is 13.880, and you've got 0, 0 here. T is equal to -4.9 t squared plus 68t. And I think that does it, right? That is it. So this would be C. So that's it for graph, okay?